You would have got on Monday's class. Laws of motion worksheet you got? Those who came for the practice class, they would have got the laws of motion worksheet in the previous class. Last Friday you came, Raghav? Then you should have got the worksheet, no? Oh, I took the class on Saturday only. Did you get the worksheet? But you did not get. If you have not got, get it soon. And if you have got, it is well and good. Avinash, you are able to hear me?
Yes, sir.
Okay. Lakshita, if you are able to hear me, please make sure your video is on. Everybody else able to hear me, right? Soumya, Kirtana, Madhuvanti, am I audible? Yes, I feel I am audible. So today we are going to start a completely new chapter, Laws of Motion. Once again in tomorrow's practice class, which is going to happen in Peranglatur, you will get another worksheet of Laws of Motion where you will solve few more questions to make it more strong. If you have anything to ask, you can ask ma'am or you can ask me also. Something you want me to reteach or something you have doubt in any concept in Laws of Motion, connect back to me and clear your doubts. I think you are not there in the last class. So have you seen the video? Please see it and then only you will understand the concepts. If something you want me to reteach to you, come back to me. I'll help you in that. Okay. Today we are going to start a completely new chapter and give the heading as Work, Energy and Power. So up to now things are happening like 9th only. In 9th you studied motion, then you studied laws of motion, then you studied work, energy and power. Same way here in 11th standard, first we studied motion in straight line and plane motion. Then we studied laws of motion. Now we are studying work, energy and power. So same way how we studied our 9th standard, it goes in the same order. And once again I am repeating that without knowing the basics, like if you are not remembering the basics of 9th, you would have had some trouble in 11th. Same way if you don't remember much of work, energy and power of 9th, it may give a bit trouble to you in the 11th also. But don't worry, I will try to keep it as simple as possible. So let us start this class, and in this chapter let me first summarize what we are going to learn. I will give you a glossary, what topics are there in this chapter and how it will go, how much time it will take to finish the chapter also. So in this chapter there are, as the name says, work, energy, power. So the first part of the chapter will be work. We will be learning about work, what is work done by a constant force, what is work done by a variable force. We will learn about conservative and non-conservative fields. Then we will go to energy, where we will learn about kinetic energy, we will learn about potential energy, we will learn about work energy theorem. If everything goes fine, by today we will be done with these two topics, today itself, if everything goes fine. Then comes power, where we will learn about definition of power, relationship of power with force, and then comes one very big topic which will itself take one full class, and that is called as collision. It is not in chapter name, but collision is a topic which is a very lengthy topic, interesting and important also, but it takes time to teach. So it will consume one entire class. So everything goes fine, 2 to 3 class I will be giving the lecture to you, because each class is almost 1.5 hours. So we are going to learn the concepts in this 2 or 3 classes. Parallelly, in the practice class, you will get questions to solve and understand how the numericals are asked from work, energy and power chapter. Okay. So today our motto is to understand work, energy thoroughly. And let us start the class then. And first to give the heading as work, subheading as work. Okay. Now let me ask you, today he is not there, our boy of the day, what is his name? Lalit Ramana is not there, Peace is there in the class. Okay. So work, Mr. Karnish, what is work? Oh, you are Harin Krish, I am confusing in that, yeah, okay, Harin Krish, what is work? What you say? Force into displacement. Good. What will you say, Karthikeyan? What is work? Ability of to do something is work. Okay. Raghav, what is work? Capacity of the body to move an object is work. Okay, Srinidhi, yes, you are trying to say something, please.
Sir, work is the force taken to displace the object.
So can I say work is force?
No, sir.
Then you said work is force taken to displace an object. Okay, something good. Yes, Rayatanya, what is work? Same means same to him or same to her? Same to everybody. Same to her. So work is force that moves the object.
No, sir, force applied to displace someone.
So can I say work is force? No. Okay. So generally some people think that, like how you even Karthikeyan said, something, ability of doing something is called as work. So if I am eating the food, am I doing a work? Ability to eat, is it work? Yes. We are writing something, is it work? Ability to write, it's work. Okay. If I am sleeping, ability to sleep long, is it a work? No, why? Not doing something. Sleeping is also activity only, no? If we are awakening at night and fully playing game on console, is it work? Activity, playing game, yes. So basically, the definition of work in English and definition of work in physics is not same. General English, work means something that you do. If you do something, we are doing some work. I am playing football, I am doing my work. If parents are saying go and do your work, it means they are asking you to study. Because they think studying is your work, isn't it? If your parent is saying go and do your work, it means what? They are asking you to study. Am I right? But in physics, as some people have told, work is said to be done only if a force is capable of displacing an object. If there is no force, there is no work. If there is force, but there is no displacement, there is no work. Are you getting my point? So write the definition first. Work is said to be done. Work is said to be done when there is a force displacing an object. Work is said to be done when there is a force displacing an object. Okay, but don't write this definition in the school exam. It is layman's definition, okay for 9th standard, but you are in 11th standard now. Now write the definition of 11th standard, write that. Work is the dot product of, work is the dot product of force and displacement. Work is the dot product of force and displacement. Now this will fetch you marks in the examination. This looks like some 11th standard definition, isn't it? Work is dot product of force and displacement. It means if I am having force vector and I am doing dot product with displacement vector, what do I get? I get work. Now tell me, dot product is also called as vector. Scalar product. Sorry, I am not well basically. Somehow I came for the class. Yeah. So work is dot product of what and what? Force and displacement. So since it is a dot product, it must be a what quantity? Scalar. Sorry, quantity. So if you remember the dot product definition, whenever two vector quantities are multiplied by using dot product, their result is scalar. Since work is dot product of force and displacement, it is a scalar result. I hope you are getting my point. So work is not vector, work is scalar. And you know very well, A vector dot B vector is equal to magnitude of A into magnitude of B into cos theta. Same way work will become equal to F S cos theta. Write it down. Work done is equal to F S cos theta, where F is force, S is displacement, and theta is angle between force and displacement. Very important. Angle between force and displacement. So very clearly visible to us that work will depend upon three quantities. One is force, one is displacement, and one is the angle between force and displacement. It means there are three possibilities. That is, if theta is less than 90 but more than 0, theta is equal to 0, and theta is less than 180 but more than 90. Are you getting your point? Basically, I can take this as one category and I can draw another category. That is theta more than 0, less than 90, theta equal to 90, and theta less than 180 and more than 90. Are you getting? 0 to 90, 90 and more than 90. Three categories I have made. Are you getting what I am trying to say? See, the angle I am dividing as 0 to 91 category, 91 category, and 90 to 180 another category. Tell me one thing, cos 0 is how much? Cos 30, cos 45, cos 60, 1 by 2, cos 90. So cos 90 becomes 0, isn't it? But this value will always be positive value. Do you agree with me? What is cos 120 degree? Cos 90 plus 30, which is minus sin 30, which is minus 1 by 2. Negative answer came. What will be cos 150? Cos 90 plus 60 minus root 3 by 2. So whatever values you are going to get where theta is going to be more than 90 is always going to be negative. What I come to know by this? I come to know that work done can be positive, work done can be negative, or work done can be 0. All possibilities are there. Work can be negative, work can be positive, work can be 0. Totally depends upon what? Depends upon the angle between force and displacement. If force and displacement have an acute angle between them, we are going to have a positive work. If it is going to be a 90-degree angle between force and displacement, we are going to have 0 work. If we are going to have more than 90 degree but less than 180 is obtuse angle, we are going to have a negative work done. I hope you are able to get my point. So before writing this, you can give the heading as positive, negative and 0 work done. Positive, negative and 0 work done. So when the work done is positive, if theta is acute. When the work done is negative, if theta is obtuse. When the work done is 0, when the theta is perpendicular, that is 90 degree. I hope it is clear to you. Let me know if you are done with this. Have you copied? Everybody? Srinidhi, if you are done laughing, copied? Okay. Now please pay attention. Please pay attention. Let us try to understand the meaning of theta acute, obtuse or 90. I am having an object and I am applying a force in this direction. The body will obviously move in the same direction. If it is able to overcome the frictional force, it is going to move in this direction only. So displacement also will be in the same direction. Force in this direction, displacement is same direction. Theta is how much? If force is applied in this direction, or if force is applied in this direction and displacement happens in this direction, then theta is how much? 90. If force is applied in this direction and displacement happening in this direction, then only theta is 90 degree. Am I right? That's what we learned now. We learned that theta is 90 degree, then the work done is 0. Theta is 90 degree, the work done is negative. Theta is 0 degree or acute angle, the work done is positive. My question to you is, how is it possible that angle between force and displacement be 90 degree? I am applying the force in this direction, how can the body go in that direction? Or if I apply a force in this direction, how the body can go in that direction? Impossible, right? If I move the body upwards, it can go upward only, no? Once again theta will become 0. I hope you are getting what I am trying to instigate inside you. The thinking that how theta can be 90 degree, how theta can be obtuse. Theta being acute is visible to us. Yes, quite visible. Object is there, I am pulling it. It will come towards me. Theta is 0 degree or acute angle. I can pull like this also. Any problem? No problem. But in both the cases, the body will pull towards right, so displacement and force are in same direction, quite understandable. But force and displacement having an angle of 90 degree is not understood by me at least. I don't know how much you are understanding. And displacement and force being opposite is highly difficult to understand. I am trying to move the object there and the object is coming towards me. Possible, huh? You are having a box, you are trying to move it towards the wall and the object wants to come this side. Possible? I don't think possible.
Then what if resultant force is in the perpendicular direction?
Resultant force can be perpendicular only if the force is acting this direction, no yaar? Resultant means what? Downward, upward. Force is applied. Upward is more than downward. Then only it can be this side, no? Or like this and like this force is applied. Resultant can be in this direction, no? If the resultant force is in this direction, Srinidhi, then the object will also move in the same direction, right? How is it possible that the force is applied in the upward direction and the body is moving towards the right hand side direction? This concept should be very clear to you. When I said that theta is obtuse or theta is 90 degree, you wrote for the sake of writing. But how much you understood this? That is what you are going to learn now. Pay attention. It means from our childhood till today, till now, there is some mistake in what we are learning. What mistake is there? When I say work done is 0, when I say work done is positive, when I say work done is negative, it is not the correct way of saying. Whenever I say work done, I should specify work done by whom, work done by which force. Now I will make you understand this. So for example, imagine there is an object which is being applied by a force towards right hand side direction. This applied force is greater than the limiting frictional force, which makes the object move towards right hand side. If I ask you, what are the forces acting on the body? What will you say? Only applied force. Frictional force acts, very good. What else acts? Gravitational force, very good. What else acts? Normal force, very good. That's what we did not see. When an object tried to move towards right, only the applied force is acting towards right. There is a frictional force acting. Acting where? Opposite to applied force. Mg is acting, weight, where? Downwards. Normal or reaction acting where? Opposite to mg. Perpendicular to surface. But the body will be displacing in which direction? This direction only, no? Now you can understand that work done by applied force is positive, work done by frictional force is negative, work done by normal force or weight is 0. Are you getting my point? So in this case, when an object is being pushed or pulled and the body moves in one direction, like if you remember a 9th standard, a very famous example is there of 0 work done. A porter taking the luggage on his head and walking in the platform. Many of you would have studied this somewhere. Studied and wrote the exam, passed and came to 11th also. But how many of you understood in the case of porter taking the luggage on his head, which force is 0? Which work done is 0? Work done by the gravitational force alone is 0 there. Work done by porter is not 0. If you take one box on your head and you walk, work done by you is not 0. You are moving in the same direction, applying a force, muscular force. So work done by you is positive only. Work done by gravitational forces, work done by normal forces, 0. Work done by frictional forces, negative. Are you getting my point? So whenever I say work done, you should ask me or ask yourself, work done by whom? Work done by the applied force, work done by the frictional force, work done by the normal force, or work done by the gravitational force. I hope you understand now. So you can draw this diagram and then you can write somewhere, work done by the applied force is how much? Positive. Work done by the frictional force is how much? Negative. Work done by the normal force or work done by the weight is 0. Please copy it down, tomorrow you will forget this. Now you are remembering, tomorrow you will forget, before you forget, copy this. I hope it is clear to you the concept of negative work done and 0 work done. Positive is clear already. If there is any doubt at any point of time, feel free to ask me. I will be more than happy to clear it. Yes. Because n is acting in the upward direction. Displacement of the body is happening towards the right. What is the angle between normal force and displacement? 90 degree. Understood? Weight acting downward, body moving towards the right. What is the angle between mg and displacement? 90 degree. That's why it is 0. Got it, Raghav? Yes.
In that worksheet you asked on some impulse graphs
Okay, I'll check that. You told you not received the worksheet. Yeah, that's the worksheet we gave last week for laws of motion, where impulse question was there, that triangle question. I'll talk about that. Can I proceed further? I hope you have written this. Okay. So when I am saying that work done is equal to force into displacement sorry, into cos theta, that time there is a body, some force is applied and the body is getting displaced. This force that we are applying, suppose we are applying 10 Newton and the body gets displaced by 2 meters, assume. Then we come to know that the work done is 10 into 2 into cos 0. So work done by this force will be how much? 20 joules. Wherever you wrote a definition of work done, please write a units also. SI unit will be how much? Joules, which is Newton meter, also called as joule. And what will be its dimension? Force and displacement. So ml2 t power minus 2. ml t power minus 2 is force. So ml2 t power minus 2 will be work. Coming back. So please pay attention about one thing. So if we have a body which is having a force of 10 Newton applied on it, and the body gets displaced by 2 meter, we say that 20 joule of work is done. Imagine practically, if I ask you, come here, take the chair and pull towards me with a force of 10 Newton. Can you do that literally? You cannot. You cannot measure 10 Newton, right? You can pull it. You can bring it near to me. But if I ask you, apply a force of 10 Newton only, is it possible for you to do that? No. Practically not possible. Theoretically possible. If I have some machine which can give a constant force, then it is possible. But if I am using my hand to pull something, push something, I cannot give a constant force. So whatever you are learning till now is basically work done by which force? Constant force. Are you getting my point? So wherever you wrote the formula Fs cos theta, it is work done by which kind of force? Only constant force, because F is a constant here, not changing. Then what will be the work done by the variable force? Next heading is that only. So next heading is work done by a variable force. Yeah.
In this image you put applied force, no, sir?
Yes.
So if you apply a force means how can the object due to frictional force go that side?
Where is the object going that side?
No, sir, you said the frictional force is going to apply in the
Opposite direction. Yes. But the body is moving towards right only.
yes, sir.
So work done by the frictional force will be, don't think it should be displacement of because of F, not like that. Body where it is getting displaced, and what are the forces acting on the body. So that time there are 4 forces acting. This work done by this force alone is positive. This will be 0, it will be 0, and this will be negative.
So the question they ask find frictional force and
Find the work done by the frictional force. Then you will write frictional force value into displacement into cos 180. Answer will come automatically negative. If they ask what is the work done by the normal force, 0 directly, because whatever you multiply into cos 90 you want to do, it will give you 0 only. Getting my point?
yes.
Yes. So now next heading is work done by a variable force. Give the heading as work done by variable force. Work done by a variable force. Okay. So as I said now, I will give time for copying. Please pay attention. Please pay attention. Very simple thing. Please understand this. So now I told you that there is an object which was given a force F, displacing the object to displacement S, and angle between them is theta. So work done is equal to Fs cos theta. But possible that, Avinash, you want to say something? Your mic is, yeah, your mic is unmuted. Yes. So if we have a variable force, it means what? The force is going to change continuously. Then how will you find the work done? Integration, not differentiation. Yes. What we do, you see? So work done by a variable force given by the formula, work done is equal to integral of f dot dx from limit x1 to limit x2. First you copy this. I'll explain this to you. First you copy this. Integral of f dot dx from limit x1 to limit x2. So for this you must know integration. I hope everybody knows integration basics. Though it comes in 12th standard in mathematics, but basic integration you know by now. I'll give a question now to make you understand this concept. But before I give a question, understand what is the concept of it. Please pay attention. I will give time for writing if you want to write something. So there is an object. On an object, there is some force acting, and this force is a variable force. If it is a variable force, they will define the force. as for example 3x square plus 2x plus 6. It means what? As displacement is changing, the force is changing. When x is 1, it will have different force, x is 2, it will have different force, x is 3, it will have different force, isn't it? So whenever they give you a variable force, what they do? They give you the equation of variable force, following which the force is varying. It's not like they will give 1 Newton, 2 Newton, 6 Newton, 9, they will not give like that. They will give you force is varying following the equation so and so. So if the force is having an equation of so and so, what I do, for a small displacement dx, I try to find the work done. So that will become small work done dw, which is equal to f dot dx, right? Small displacement dx, we found small work done dw. This concept of integration we are going to use throughout 11th and 12th, physics and math. This concept of integration we are going to use not only in today's class, in lot of concepts of physics and math we are going to use this, where we will take a small value and we will integrate over the limits to find for the complete value. So integration always gives for the complete thing. So now I find for a small displacement, if I have the starting point known, it is x1, it can be 0 also. If I have the ending point known, that is x2, then don't you think that the total work done, which will be integral of dw, it varies from 0 to w, will become equal to integral of f dot dx, varying from where to where? x1 to x2. Integration of dw will be w, so I will get this equation. Got it? So integral of w, dw will be w, and upper limit is w, lower limit is 0, so w minus 0, so it will become w on the left hand side. Right hand side, same thing I have written, what I have written here. So if the numerical comes, the same question comes suppose, and they ask you what is the work done to displace the object from x is equal to 1 meter to x is equal to 5 meter. Can you find the answer? First you write what you want to write and then solve this question. There is a question given to you now. I have given you the force value, how much? 3x square plus 2x plus 6, and I have asked you to find what is the work done to displace the object from x is equal to 1 to x is equal to 5 meter. Solve it guys, give a try. If you know basic integration, you can solve it. If you don't know, then you will have struggle. Can I show? X is equal to 1 to x is equal to 5. X is equal to 1 to x is equal to 5 meters. Any answer? If anybody has any doubt, please ask me. Any answer? I hope you know integration. Then why the answer not coming? Doing? 3x square plus 2x plus 6. F is equal to 3x square plus 2x plus 6. And they are asking you to find the work done from where to where? 1 to x is equal to 5. It will become 3x square plus 2x plus 6 integration. This much dx, f dx, isn't it? Now, if you don't know the integration basics, definitely you cannot solve this question. So, what I will do step by step. So, first integration of 3 I will come outside, x square dx, from where to where? 1 to 5, plus 2 integration of x dx, from where to where? 1 to 5, plus 6 integration of dx, from where to where? 1 to 5. Let us check. Is this clear to you? What step I have taken is clear to you?
Sir, is the answer 170 joules?
170?
2 joules.
Same answer is told by Shrish also. Let me check. So, after it will become 3. Integration of x power n dx is how much? What is integration of x power n dx?
X power n plus 1 by n plus 1.
Yes, x power n plus 1 by n plus 1. So, what will happen? 3 into x power 2 plus 1 by 2 plus 1. Limit from where to where? 1 to 5 plus 2 into, what is integration of x? X square by 2, isn't it? From where to where? 1 to 5 plus 6, what is integration of dx? X from where to where? 1 to 5. So, 3 will get cancelled. It will become x cube. So, first we will put 5, upper limit minus lower limit. So, 5 cube minus 1 cube plus 2 gets cancelled. 5 square minus 1 square plus 6, 5 minus 1, upper limit minus lower limit. If you are understanding this step, then come to the value of work done, which will become equal to 5 cube is how much? 125 minus 1 is 124 plus 5 square is how much? 25 minus 1 is 24 plus 5 minus 1 is how much? 4. 6 4s are 24. How much you are getting? 170. That is answer. If you are not knowing integration, you cannot solve this question. If you have problem in this step, how this step came, then your integration is weak. Work on that. If you want some attention on integration, then in your next practice class, you can ask your Alamelu ma'am to help you with basic integration. This is very basic level of integration. Only one formula is used, which is integration of x power n dx is equal to x power n plus 1 by n plus 1. Loudly. How I take limits? Okay, so I will write one more step for you. So here it became x power 3, lower limit is 1, upper limit is 5, plus x square, lower limit is 1, upper limit is 5, plus x, 6 into x actually, upper limit is 5, lower limit is 1, right? After this only you have doubt, isn't it, Raghav? What we do, in this variables, I have to add upper limit minus lower limit. Always remember this. In integration, we always do upper limit minus lower limit. What is upper limit here? Put in the equation of x, what will happen? 5 cube minus 1 cube. What is the limit here? What is the limit here? 5 to 1? 1 to 5 I mean. So upper limit is 5, 25 minus 1. Once again upper limit 5 minus 1, 4. That's how it came. 6 came from our step, man. 6 was constant taken outside. 6 into 5 minus 1, no man. Upper limit minus lower limit. So I did 5 minus 1 and multiply with 6. Or you can do like this also. 6 into 5 minus 6 into 1. Same thing will come. 30 minus 6, how much? 24 only, no? Your wish. Any doubt in this? Any doubt in this? So Shweta is asking, what if I put an object from a building? That is, I think what I mean is, if the object is dropped from a building, what are the types of force acting on it? So if an object is falling down, then how will the work is calculated? I think she is asking that. So if the object is falling down, what are the forces acting on it? Mg downwards. Okay. If it is falling down, normal will act? No. Normal can act only if it is on the surface. So there will be only mg acting downwards, work will be done by only mg. If we consider friction by air will have friction, right? Then work done by frictional force also will be calculated, if it is considered. If they have told not to consider the friction of the air, then only the work done by the mg, that is weight, will be calculated, and the direction of force will be same as displacement direction, theta will be 0. So work done by the gravitational force will be positive, work done by the frictional force will be negative, but until they give the value of frictional force to you. Okay, can I proceed further? Is it clear to you? One more way is there. Apart from constant force directly being found by Fs cos theta and variable force work done be found by integral of f dx, we have another way of finding work done. Write the heading as work done by force displacement graph. You want to write something from here? Is it clear? Can I go to the next page? Can I go to next page? Next heading is work done by force displacement graph. Work done by force displacement graph. So sometimes you will have a graph like this. You may have a graph on y-axis force, x-axis displacement. Remember, write it down somewhere. Remember that area under the force displacement graph, area under force displacement graph gives work done, gives work done. In bracket you can write taken with respect to displacement axis. Always remember that, very important. It means if I am having a graph like this where displacement is here, force is here, and the graph is like this, then you will not take this area, rather what you will take? Rather you will take this area. Are you getting my point? Always the calculation of work done should be happening with respect to displacement axis, not the x-axis. Please remember that. If it is x-axis displacement, then I will find what I will find? This area I will find. If it becomes displacement in y-axis, I will find the area under the y-axis. I hope you are understanding this. So sometimes a graph may be given to you and they may ask you to find the work done. In that case, you must take the area under the graph. Is it clear to you? So there are three work dones we have learned till now. Three ways of finding work done. If it is a constant force, we are finding work done directly by using Fs cos theta, where F is the force, S is displacement, theta is the angle made between force and displacement. We learned that work done can be positive, work done can be negative, work done can be 0. If theta is acute, that is less than 90, more than 0, it is going to be positive work done. If theta is going to be right angle, work done is going to be 0. And if theta is going to be obtuse angle, more than 90, less than 180, it is going to be a negative work done. I told you how it can be negative work done. Work done by a frictional force is negative work done. Work done by a normal force or work done by a gravitational force is 0 work done. And work done by the applied force is positive work done, because displacement and the force are acting in the same direction in the applied force. I hope it is clear to you. Then we found how to find the work done by a variable force. I told you for variable force we use work done is equal to integral of f dot dx, where f will be given to you in terms of x. Just integrate the equation, put the upper limit, lower limit, get the work done. And third, I taught you by graph. If you have force displacement graph given to you, find the area under the graph assuming the displacement axis, and whatever area you get, that area gives you the work done. Can I proceed further? Up to here things are clear? Okay. If you have done with what I have told now, give the heading as kinetic energy. Before that, let me introduce to you energy. Give the heading as energy. Give the heading as energy. So Somebody is asking me to explain how to calculate integration. Okay, that integration, if I start teaching you now, it is another class itself, where I think you should know integration to understand work, energy and power. But let me spend 5 minutes of time, because some of you may be confusing in integration still. So for you, I am teaching, I will take 5 minutes of time and I will teach once again integration to some people. So before talking about energy, let me talk about basics of integration that we are going to use in this chapter. So what integration I am using in this chapter is only one type of integration, which is integration of x power n dx is equal to x power n plus 1 by n plus 1. So limit, this is called as lower limit, this is called as upper limit. Whenever you integrate a function, after integration, in the variable spots, you will put upper limit minus lower limit. For example, if I have a function, for example, the function is y is equal to x square plus 2x plus 1, and I am going to integrate on both sides, suppose. So I want to find integration of this dy. So if I am finding integration of dy, it will become integration of x square plus 2x plus 1. Let me write dy by dx actually, yeah, so this is dx, so here dx will come. And if suppose upper limit is from some value, suppose the value is 2 to 4, then what do we do? First we will integrate the function by using the formula x power n dx is equal to x power n plus 1 by n plus 1. So if you see, I will do it individually. First I will write integration of x square dx from where to where, limit from 2 to 4, plus integration of 2x dx from where to where, 2 to 4, plus integration of dx from where to where, 2 to 4. Now when I integrate it, then this x square becomes x cube by 3, isn't it? And limit is from where to where, 2 to 4, plus when I integrate this, 2 will come outside, it will become x square by 2, limit from where to where, 2 to 4, plus integration of dx is how much, x, limit where to where, 2 to 4. After this step, what do we do? In the place of variable, you place the upper limit minus lower limit. So here it is 4 cube, so I can write like this also. If you are confusing, I can write 4 minus 2 the whole cube. Possible, both are going to give the same result to you. Whether you do 4 cube minus 2 cube, how much will come? 64 minus 8. Okay, that only we should do, sorry. So upper limit is, first we will put 4 in this, so it will become 4 cube minus lower limit is 2 cube divided by how much, 3, plus 2 gets cancelled, upper limit is how much, 4, 4 square minus 2 square, plus upper limit is 4, lower limit is 2. When you solve this, we will get the answer. So always after integrating the function, what we should do? In the place of variable, you have to put upper limit minus lower limit. That is the how you solve integration. Coming back to what we were talking. So what is energy? Anybody? Yes, Mr. Muhammad Arshad. What is energy? Any idea? Whatever you know, you may be right or wrong. Give a try. Unmute yourself first, man. Whatever you know, you can say. Right or wrong is not a big deal. Arshad, please try.
Can't define it in a sentence, sir.
Whatever you define in Tamil, Urdu, Malayalam, I am okay with anything. Give a try. What is energy? Should speak here.
Energy applied by something to do a certain work, sir.
Energy is energy applied by something. Okay, I will come back to you. Soumya, I will give a chance to you, Srinidhi. Wait for some time. Yes, Soumya.
Sir,
Yes, what is energy? What you know, right or wrong, don't worry about that. Give a try.
work done by time.
Work done by time. Okay, Lohita Shri, what is your opinion? Work done by time is energy.
Ability to do work.
Ability to do work. That looks more suitable, isn't it? Write the definition of energy. Capacity of doing work is known as energy. That is, capacity or ability of doing any work is known as energy. So always remember that work done by time, Soumya, is actually power. Okay, it's not energy. Work done by time is power. We'll come to that also later. But first, what is energy? Energy is the capacity of doing work, or we can say capability of doing work, or we can say ability of doing work. So if there are two people, one has more energy, one has less energy, the person who has more energy can do more work. So it is the ability of doing work. Since it is ability of doing work, its unit is same as energy. So what will be its SI unit? Joule. Its dimension will be same as ml square T power minus 2. So its units and dimensions are same as work done, isn't it? Reason is, it is the ability of doing work only. It is not a different quantity. It is a kind of work only. Fine. So energy, do you know that energy of this whole universe is a constant? This whole universe is there, no? Whatever universe you know, observable universe. This universe has a constant energy. You cannot create energy. You cannot destroy energy. You can just convert energy from one form to another. You may say, sir, I am creating light energy. I am creating wind energy. By burning fuel, I am creating heat energy. Then how you are saying I am not able to create energy? I am creating only? No. You are just converting electrical energy to light energy. Electrical energy, how it came? Assuming coming from some power plant. There once again some kinetic energy would have been converted into mechanical energy, would have been converted into electrical energy, like that. For example, if I take a solid example to you, like a hydroelectric power plant. Water is made to store on dams, right? Generally, hydroelectric power plants will be in the hilly areas. In Tamil Nadu, we have one which is in Mullai Periyar, in Theni. In Theni district, you have one hydroelectric power plant in Tamil Nadu. Very famous dam, border of Kerala and Tamil Nadu, which is near Theni, Kambam, Kumli, that area, and the dam name is Mullai Periyar Dam. That dam, if you go there and see, if you get a chance to see, in the bottom they have turbines. First what they do, because of rain, the water gets deposited in the reservoirs, tanks. That has what? Potential energy. By using pipe, they make the water to come from the tank, that is the reservoir, to the bottommost part. Conversion of potential energy into kinetic energy. When the water comes, hits the blade of the turbine, blade starts to rotate. When it is rotating, it is creating mechanical energy. Inside the turbine, we have a coil and we have two magnets. In 10th standard you studied generator, I think it was removed from syllabus. So there is a coil and there is a magnet. The coil starts to rotate. When it is rotating, mechanical energy is converting into electrical energy. You get current. Once again, electrical energy is sent to you and you are once again converting into light energy. If you touch it, it will be hot, heat energy. Like that, what we are trying to do, we are trying to convert energy from one form to another. So basically, the potential energy of the water kept in the dam is converted into light energy by so many processes. I hope you get my point. That's why I say that the whole universe has a constant amount of energy. What we are doing? We are keep on changing energy from one form to another. And what we are trying, we are trying to do the maximum of it. For example, what is the best solution for energy? Nuclear fusion reaction. Are you aware about that? Now how we are getting power? We are getting power for the maximum source. What we are getting is thermal power plant, maximum in India. How thermal power plant works? By burning coal. We are heating water. Water is becoming steam. Steam is passed through pipes. It goes and hits the blade of turbine. turbine rotates, coil rotates, current is produced. Instead of coal, if you are using nuclear waste, not waste, nuclear fuel, for example, plutonium, uranium, and heat the water. Once again, water is heated, boiled, steam, blade, turns, current. Remains the same process. Instead of coal, if you are using uranium, it is called as nuclear power plant. If you are using wind energy to rotate a turbine, it is called as wind power plant. If you are using water to rotate a turbine, it is called as hydroelectric power plant. And if we are able to use fusion reaction, you know what is fusion reaction? Fusion reaction happens in sun. In sun, the hydrogen and helium is burning to create energy, combining actually. Hydrogen combining to become helium, and helium is having energy released, that we are using as fusion reaction, clean energy. So from where fusion happens, you know? Fusion happens inside the nucleus, which we cannot even see. So every nucleus has a capability of producing fusion reaction, huge energy. One day, if we will be able to harness that energy, then all our space missions which are stuck today, if you want to go to some other galaxy, can you go? By today's technology, we cannot. Even Mars we have not gone till now. We have gone maximum to moon only, theoretically. I mean, America went. Human beings have not crossed moon, right? But if we are thinking of going to some other galaxy and seeing other planets, it is possible only if someday you are going to use nuclear fuel, that is fusion reactors for running the engine. And maybe we develop a technology by which we can move more than speed of light or equal to speed of light. That is still a very big thing. It may happen, who knows? Not now. 500 years from today, it may happen. Today we are talking like possible, but anything is possible. Before 50 years, somebody says mobile phone will come, which will be held in hand, we can talk, they will laugh only. If 200 years before somebody told aeroplane will fly in the sky, they will laugh only. But as the technology is advancing, we cannot know what things we can do in future. We cannot imagine actually. So energy of the whole universe is a constant value. And what we do? We convert energy from one form to another form. So basically there are so many energy. Just now I told you, light energy, wind energy, heat energy, nuclear energy, chemical energy. There are so many energies, out of which what you are going to learn in your syllabus is only two energies: kinetic energy and potential energy. So one by one we will learn. First we will talk about kinetic energy. What is kinetic energy? Any idea? Because of? Okay. I am having a pen in my hand. This is a pen. Can this pen kill you? Difficult to imagine. How can this pen kill me? Imagine this pen I am throwing at you at 3000 meters per second. It can kill you, right? The same pen that I am holding in my hand can take your life. You know why? Not because of its mass, because of its energy. And how did that energy came? Because of its velocity. That is what is called as kinetic energy. Write down: energy possessed by the body, by the virtue of its velocity or by the virtue of its motion, whatever you want to write. Energy possessed by a body, by the virtue of its velocity, is known as kinetic energy. Okay. If I ask you what is the formula of kinetic energy, what will be your answer? Most of you will say half, and I will say it is wrong. ME square. You are making your own. Then? Oh, what is the ME? Electron. No ME. No ME, sorry. Why is this formula is not correct? Actually it is very solidly there in your head. In 9th you studied this, half mv square, half mv square, half mv square, half mv square, kinetic energy only. Today I am saying it is not true. Where is the thing going wrong?
So it only applies for objects in mass having mass.
Oh, not having mass? Then there is no kinetic energy itself, right? Because m is 0, kinetic energy will be 0. Let us derive the equation, then you will understand where the things are going wrong. Okay? So now pay attention, I will give time for copying. Please pay attention, learn the derivation of this. And then we will understand where it is wrong. So you know that v square, I am writing here as we know. V square is equal to u square plus 2as. From here, what will be the value of s? V square minus u square by 2a. Do you agree with me? And we know that work done is equal to force times displacement. Just now we have learned cos 0 if it is moving in the same direction. So force, which is equal to mass into acceleration. And what is displacement? V square minus u square by 2a. A gets cancelled. What I get? I get this work, and this work only as stored as the kinetic energy. What is that? That is become equal to 1 by 2 into m into v square minus. So kinetic energy is not half mv square. Kinetic energy is half m v square minus u square. Then why from your childhood they are teaching wrong to you? They are not teaching wrong to you. They are assuming that u is 0. Then kinetic energy will become half mv square. So kinetic energy being half mv square is true only for the scenario if object starts at rest. If car is already moving at 10 meter per second, what is the change in energy if it acquires a velocity of 30 meter per second? That time you cannot use half mv square. You have to use half m v square minus u square. Are you getting my point? So the formula of kinetic energy is half m v square minus u square, and obviously for u is equal to 0 it will be half mv square. Copy it fast. Copy it down fast. Let me know if you are done. Shall I proceed? Okay. Now please pay attention. Whatever derivation I have made, this derivation is done by the assumption that force is a constant force. Am I right? I directly took work done as F dot S, isn't it? I not used work done as integration of F dot dx. which is unfair actually, because sometimes work can be force can even be variable force. So let us derive the same thing by using calculus. Sometimes they will mention in the examination, derive this kinetic energy expression with the help of calculus. So let us derive that also. Same derivation we will do, but in a different way. Earlier I did by a different way, I am going to do now by a different way. Let us see what way I am going to do. Pay attention, learn it, I will give time for copying. Please pay attention. So for variable force, we know that work done is equal to integration of f dot dx. Limit from where to where? x1 to, do you agree with me? Okay. Now what I am going to do, I am going to write the formula of f as mass into acceleration. Can I write like this? Now what I am going to do, I am going to write acceleration as dv by dt. Can I write like this? Do you agree with me? Then I will write m into, integration is there, m into dv into dx by dt. Can I write like this? I can write. What is dx by dt? Velocity. So I will write this work done is equal to integration of m into v into dv. Can I write like this? Now since it became a differential of velocity, I can write limit from where to where? Initial velocity to final velocity. Now work done will become equal to, m comes outside, integration of v dv from u to v. What is integration of v dv? V square by 2, which will become equal to m into v square by 2, upper limit v, lower limit u. So if I use this upper limit minus lower limit concept, then I am going to get work done which is equal to kinetic energy as, or let me write one more step, one second. Yes, I am writing here that this work done is equal to half mv square minus half mu square. Can I write like this? Don't you think half mv square can be taken as final kinetic energy, half mu square can be taken as initial kinetic energy, and I can write work done is equal to kinetic energy final minus kinetic energy initial, or I can write work done is equal to change in kinetic energy. This is called as work energy theorem. In the school for 2 mark or 3 mark, if they ask you derive the expression for work energy theorem, then they are expected to derive this only. First of all, what is the meaning of work energy theorem? Work energy theorem says that net work done is always equal to change in kinetic energy. And how we derive it? We derive it like this. Also from here you can write one more statement. So either I can go in this direction, write this, or I can go like from here I can write work done is stored as kinetic energy, and kinetic energy will become equal to half m, if I take common, v square minus, same thing I derived. I hope it is clear to you. I hope it is clear to you. Is it clear? Sure? Copy it fast. If it is clear, copy it fast. Take the attendance. So for this you can give the heading as work energy theorem also. For this topic you can give the heading as work energy theorem also. Done? Can I proceed further? Let me know if you have any doubt up to now. Shall I proceed? So what we came to know? We came to know that work done is equal to change in kinetic energy, and kinetic energy formula also we came to know that it is not half mv square alone, it is half mv square minus u square. If u is equal to 0, yes, then half mv square. Okay. Now, next heading is relationship of kinetic energy and momentum. Relationship of kinetic energy and momentum. Very simple small topic, pay attention. So what is kinetic energy formula? We know half m v square minus u square. If I assume u is equal to 0, then kinetic energy will become equal to half mv square. If I multiply and divide by m, then I am going to get kinetic energy is equal to 1 by 2 m into m square v square. Can I write like this? Why I am doing this? Because mass into velocity is what? Momentum. So I will be able to get kinetic energy is equal to momentum square by 2m. Understood? So from here we get momentum is equal to root of 2 into m into kinetic energy. This is the relationship between momentum and kinetic energy. What is that? Root over 2m k is p. So momentum and kinetic energy are related. Questions will come from here. Numericals will come from here. If you have understood this, copy it fast. Let us take some questions now. A lot of theory we learnt. Some questions we will take.
Sir, this only applies for if the initial velocity is 0.
Yes, only for that condition. Shall I give a question? If you have copied this, everybody, please take the notes. Please take the question. Question is, please copy down, guys, everybody. A bullet weighing 10 gram. A bullet weighing 10 gram is fired with a velocity. Is fired with a velocity of 800 meter per second, fired with a velocity of 800 meter per second. After passing through a mud wall, 1 meter thick, 1 meter thick, its velocity decreases to 100 meter per second. Its velocity decreases to 100 meter per second. Find the average resistance offered by the wall. Find the average resistance offered by the wall. Find the average resistance offered by the wall.
So resistance means force.
Yes, force. Let me know if you got any answer. It's a very simple question. Believe me. Loudly. 3.5 Newton. Very less you are getting. 3500 Newton. Not correct. What is the question saying first your understanding? Question is saying that 500 Newtons. Let us check. They told that there is a mud wall. Okay, this is a wall. A bullet is fired. Bullet has a velocity of how much? Initial velocity of 800 meter per second. They say that when it goes in the mud wall, how much distance it travels? 1 meter it travels, and its velocity becomes how much now? Its velocity, final velocity becomes equal to 100 meter per second. This is the question, isn't it? They are asking what would have been the resistance offered by the wall. So don't you think here velocity is changing? So kinetic energy is changing. So we will use work energy theorem. Work energy theorem says that work done is equal to half m v square minus half m u square. Now what is work done? Force into displacement is equal to 1 by 2 into m v square minus u square. Do you agree with me? They are asking to find the force, that's all they are asking to find. So 1 by 2, what is the mass given? Bullet mass how much here? 10 gram. So 10 into 10 to the power minus 3 times, what is v square? 100 square. What is u square? 800 square.
Minus 3150 Newton.
I think that is correct. Divided by displacement, how much is that? 1. So when you solve this, you will get minus 3150 Newton. That is the answer. Why minus came? Because the force is a resistive force acting in the opposite direction, isn't it? That's why minus value will come. But the answer is 3150 Newton. Negative sign indicates that the force is acting in the opposite direction, stopping its velocity. Avinash, where you went wrong?
Sir,
So now I understood, sir.
Okay, yes.
after finding 3150, you should not substitute in the momentum relation, sir.
What is the requirement? They are asking to find the force. Over. They are not asking anything else to find. Just asking to find the force. Just because I taught momentum now, it's not like the question should come from momentum only. I asked to find the force is over. Take another question, guys, fast. Take another question, please. If kinetic energy of the body increases by 300 percentage, if kinetic energy of a body increases by 300 percentage, if kinetic energy of a body increases by 300 percentage, by what percentage will the momentum of the body increase? Will the momentum of the body increase? Yes, it is getting rectified, don't worry. I am just talking simply.
Yes, sir. No, I didn't, sir.
Now it's fine, right? Okay, yeah. So now I have all the four options. Somebody saying 100, somebody saying 200, somebody saying 300, somebody saying 400. Srinidhi, what you are saying? Nothing. What is the answer you are expecting?
I don't
I'm
know.
expecting 100%.
Sri Krishna has browsed and got the answer as 100%. Okay. Shoaib Ahmed, what you are expecting?
So 300.
300.
I'm not
Madhuvanti?
sure of my answer, sir.
Okay, Sri Krishna. That makes it more clear that you have seen from somewhere. Okay, Madhuvanti, what about you? Any idea?
100%.
You also browsed?
No, sir.
Okay. I don't know the answer. I'm just simply saying. Let us check. Let us check the answer how much you are getting. That is the advantage in online class. Right, Karthikeyan? While studying, we can see something, we can browse something, we can do something. You did the same thing only, no? When I was teaching. You were 100% correct while attending online class? Be honest, man. Never cheated anything, nothing you did wrong? Seriously? Oh, mom is sitting next to you, that's why. Oh, you are good from hurt. Oh, very rare to find. Okay, fine, coming back. So the question is, kinetic energy is increased by how much? 300%. If something is increased by 300%, what is its value? So this is a basic question of aptitude, mathematics. If 6 times, think and speak once again. If you have 1 rupee or you have 100 rupee, 1 rupee is too less, 100 rupee note you have. I said that I am giving 100% increment to you. How much money you have now?
So 100% of that we should add.
How much is that? That's why I gave a simple number to you. Do and tell me. You have 100 rupees. I said that it is increased by 100%. Then how much money you have now? 2 rupees only you have. 100 rupees you had. 200 you have. Common sense. 100% of 100 is 100. So 100 plus 100 is 200, right? Confusing you 100? Now take 1 rupee itself. So you have 1 rupee and now I am giving you increment of 300%. Then how much rupee you have now? 3 rupees. 4 rupees. No, 1 rupee already had, right? Plus 300% of 1 will be 3. So 1 plus 3 is 4. So in kinetic energy, if I am giving 300% more kinetic energy, what is the new kinetic energy? 4 times the old kinetic energy. Do you agree with me? So if you have assumed that kinetic energy is 3 times kinetic energy, you are wrong. There itself you have gone. They are asking you to find what is the value of momentum. That's the question actually. We know the relationship. Kinetic, that is momentum, is equal to root of 2m into kinetic energy. So what will be P dash? P dash will be root of 2m into kinetic energy dash. What is kinetic energy dash? 4 times kinetic energy. So this new momentum P dash will become equal to root of 2m kinetic energy already existing into 4. Do you agree with me? Do you agree with me? 4 comes outside, what it becomes? 2. So P dash will become equal to 2 times of root 2m ke. What is root 2m ke? Old P. So can I say that P dash became 2 times of P? It means how much increment happened? 100%. No yaar. Then only 100% will become 2 times. If you have 1 and it became 2, it means how much increment you have? 100% increment you have. Are you getting my point? If I would have got the answer as 3p, then 200% is correct. But since I gave the answer as 2p, what is the answer? I hope you are getting my point. If 1 rupee became 2 rupee, how much increment you have? 100%. If it had been 200% increment, 1 would have become 3. Isn't it? This kind of questions will not only come in physics, it will come in mental ability, math, anywhere it can come. That is percentage increment. So 100% increment means double. 400% increment means 5 times. N% increment means n plus 1 times. Understood? If it is clear to you, copy it up and go to your homes. 5 minutes remaining, but I am finishing it now itself. I will continue my class in the next session where I am going to teach you power and collision concepts. Okay, this also is remaining. Potential energy also is remaining. Next class, I will take 3 classes at least for solving this chapter. Okay. As you copy, guys, you can start dropping from the meeting. Bye bye. Take care.
Thank you, sir.
Yeah. Shall I go pause कर दो?